Alright, good afternoon.
For the homework, cosine 37.
Okay. We are doing a little more with inverse trig functions today. So as a review here, this is the cosine inverse, also known as arc cosine of negative root 3 over 2. Same meaning, arc cosine or cosine inverse. And it says, whenever we have an inverse function, we want to know what angle has a cosine ratio of negative radical 3 over 2. And so we're trying to find the angle measure, which is why I like arc cosine. I prefer that notation because it helps you remember that arc, or we're looking for the angle. The arc or the angle. So this is the cosine inverse. It's a really messed up circle there. We're looking for the cosine inverse function. It looks more like a kidney bean. All right. Which half of the unit circle do we care about for cosine inverse? Top half. All right, so it's like a dude wearing headphones. I'm sorry.
You're so creative, I see them.
Wearing the beats.
Okay.
The beats.
So our cosine uses the top half of the unit circle. This ratio happens to be negative. Where should we look for our angle? The left side over here. Cosine is negative in quadrant 2, positive in quadrant 1. So we're going to look over here. And cosine is the x coordinate. So we're looking for the x coordinate. That's negative root 3 over 2. So what angle is that? Which angle has that cosine ratio as negative root 3 over 2? 5 pi over 6, right here. 5 pi over 6 has that negative radical 3 over 2 cosine value. Okay, cool. All right, so we're working a little bit more with inverses. Example 1. Find the exact value of the expression. Hint, draw a triangle. Find the exact value of the expression.
Apple that deal. Do I need to package that? Nice. Oh, I thought we had a worksheet today. There's a stack of books on the table.
Okay, here we go. So what we have here are some what I would call nested trig functions. You can see we have an inverse function inside of a secant function. So what we want to do is start inside the parentheses. Order of operations, start inside first. So we're going to work inside here. So imagining that's not there, then this is saying what angle has a tangent ratio of 3 over 2? Well, if I am given the ratio, then that's a triangle that I can draw. So this is tangent inverse. What half of the unit circle are we thinking about for tangent inverse? The right half. So, and that's open circles at negative pi over 2 and pi over 2. And this ratio is positive. So should I draw my triangle in 1 or 2? In 1. So this is an angle that I'm going to draw, an angle in standard position on my initial side, and I'm going to draw it here in quadrant 1. There it is. There's angle theta. Now, I can drop an altitude, just like we're really good at doing. And I can apply some labels. What can I apply?
3 and 2.
3 and 2. 3 is on the
Top.
opposite, and 2 is on the adjacent side. So our opposite side is the 3 and the adjacent side is the 2. What do we need to do? Pythagorean theorem. Find the third side. So 2 squared plus 3 squared equals our radius squared. What is our
Radical.
radical 13? Radical 13. So we found the third side. Ladies and gentlemen, we did this first thing. It said draw the angle that has a tangent ratio of 3 over 2. The tangent ratio is 3 over 2. Done. Now, we are trying to figure out, well, what is the secant of this angle that we just drew? Well, what is the secant ratio? Hypotenuse over adjacent. So that's going to be radical 13 over 2. That's it. So we're taking an inverse and using it to draw a picture. It's like we've done this before, right? Yes. So here again, I'm going to start inside my function. And this says, what angle has a sine ratio of negative 2 over 3? Okay, well, let's draw a picture. So if we're talking about sine inverse or arc sine, which half the unit circle do we care about? The right half again. So that's including negative pi over 2 and pi over 2. So the right half there. This ratio is negative. Which quadrant should I draw my angle in? Quadrant 4. So down here sine is negative. So I'm going to draw a little negative angle here. There it is. Oop, there it is. Okay, see, there it is. Oh, wait, I didn't. Okay. See, we're seeing. I don't know any more words to that. That's the problem. Okay. Is that all there is? All right. So then we can drop an altitude and assign some labels. This is the sine ratio. What sides do we have? Opposite and hypotenuse. So the opposite side is negative 2, and the hypotenuse is 3. So again, we need to find the third side, which in this case is this x side. X squared plus negative 2 quantity squared equals the hypotenuse squared. Yeah. Okay. Thanks. Know where anybody sits now. Oh, Hannah, here. You pass it. All right, and so we get x equals what? Radical 5. All right, there it is. We drew the angle. It's right there. That satisfies the condition they gave us. So now we want to figure out, well, what's the cotangent of this angle that we just drew? So what is the cotangent ratio?
Adjacent over hypotenuse?
Adjacent over opposite.
Or opposite.
So adjacent would be radical 5 over negative 2, or negative radical 5 over 2. All right, any questions for me on that? On that?
Yeah, you.
Are we done?
Yeah.
Okay. Example 2. Use a triangle. Use a triangle to write the following as an algebraic expression in terms of x. Use a triangle to write the following as an algebraic expression in terms of x. So these expressions look very similar to what we were just doing, except instead of a number like 3 over 2, we've got an x. Okay, but the idea is identical. Same exact idea. Arctangent says, hey, what angle has a tangent ratio of x? Well, wait a minute. What's the ratio if they gave me an x? X over 1. Yeah, okay. So you can turn it into a ratio, and then the same exact thing happens. We're going to draw a picture. So thinking about my unit circle, tangent inverse uses which side? Just the right side. Okay, and so I want to draw my angle. I'm assuming a few things. We are actually assuming that x is between 0 and 1. That's so that it fits inside of our unit circle, and it's positive to make life easy, okay? So we're assuming that this is a number like, 0.3 or 0.4 or 0.5, something like that. So then it's positive, so I'm going to go ahead and just draw my little angle here in quadrant 1. So there's theta. Just like we were doing, I'm going to drop an altitude and apply some labels. This was the tangent ratio, so where should I put the x? On the opposite side, and where should I put the 1? On the adjacent side. So the opposite gets the x, which I know is weird, right? I always use a y. Yeah, okay. Over 1 for the adjacent side, but that's okay. What do we need to do now? Find the hypotenuse again. Find the third side. So 1 squared plus x squared equals our radius squared. I'm going to use r. Only do 1 squared as 1 because I don't know what x is. How do I get r by itself? Square root. Is the square root of 1 plus x squared 1 plus x?
No.
Good. Leave it. It does not simplify. Only one time out of 137 million will it ever simplify. Actually, you're going to get those in the next unit, and then you'll see. But it almost never simplifies, okay? Over, plus, or minus, it just never works. So this is the square root of 1 plus x squared. It's like winning the lottery. It just doesn't happen. And now that we've completed the triangle, now we can move out and figure out, well, what is the cosine ratio then according to this angle that we just drew? So cosine is adjacent over hypotenuse, so that's going to be 1 over radical 1 plus x squared. And you can leave it like this. You don't have to rationalize that. That's a big hot mess. In fact, I should really look in the book and see if they rationalized anything. I hope they didn't. I'm not going to make you do that. Okay, here's the cool thing. You can check because these two expressions are supposed to be equivalent. You can see that it's in terms of x, which means it's something that I could graph. And so what we're going to do is in our calculators, we're going to type in cosine of arctangent. Arctangent really means tangent inverse. So using the inverse function of x. So we're going to put the original expression in y1. And then this expression is supposed to be equivalent to it. They should be equal to one another. We're saying this is equal to this. So I'm going to put this expression, 1 divided by the square root of 1 plus x squared in y2. And if they are equivalent, what should I see graphically? The same graph. They should be graphically identical as well. So I'm going to go ahead and graph that. It's a nice little hilltop. All right, and it's graphing the second one. And it's working. It's done. And I can turn one off, like I can unhighlight it. And now it's only going to graph the second one just to verify that they are the same. And yeah, it's the same. Pretty cool. So it's a nice way to, the cheater's method of seeing if they're the same or not. But it's good for checking your answers. Okay, let's try one more. Sine of cosine inverse of 3x. Again, cosine inverse says what angle has a cosine ratio of 3x? Well, where's the ratio? 3x over 1. Okay. And so we're going to think to ourselves, hey, we're going to draw a picture. Cosine inverse uses which part of the unit circle? The top half. Cosine inverse uses the top half. And again, we're going to make an assumption here. We're assuming x is a positive value, just to make life nice. But also, if this is the cosine ratio, this is the adjacent side, and the 1 is the hypotenuse. The adjacent side has to be less than 1. This adjacent side has to be less than 1. It can't be longer than the hypotenuse, right? And our hypotenuse is 1. So we're making the assumption that it's positive and that it's smaller than the hypotenuse. That's a safe assumption to make. All right? And that's really important. And so it turns out if you divide by 3 everywhere, x is between 0 and 1/3. So it's very small. That's the domain of this, and you'll see when we graph it. I'm going to drop an altitude. There's our angle theta that we create. And my adjacent side I'm going to call 3x. My hypotenuse is 1. And I need to find the third side. So 3x quantity squared plus y squared equals 1 squared. What is 3x quantity squared? 9x squared plus y squared equals 1. And I'm trying to solve for y. So I get y squared equals 1 minus 9x squared. And then we can square root that. Is the square root of 1 minus 9x squared 1 minus 3x? No, never. Never say never. It's not always true, but most of the time. 1 minus 9x squared is that length y. And now we've completed our triangle, so we can find whatever ratio we want. What is the, not cosine, what is the sine of angle theta that we just made? Opposite over hypotenuse, so radical 1 minus 9x squared over 1, which would just be square root of 1 minus 9x squared. I could graph this one as well. Clear. Sine of cosine inverse of 3x. And then the square is supposed to be equal to the square root of 1 minus 9x squared. So I have those typed in. And you just see a little bubble. And this actually goes from negative 1/3 to positive 1/3. For very complicated reasons, but that's fine. Because we could draw it over here too. All right. Kind of cool. Any questions for me? All right. There you go.
Just like babes.